it is updating in real time as Micah's changing the date, so that we are seeing it load that different image of satellite imagery. And
So the next day they got it fixed.
now all fixed. And you can see similar weather patterns. Something was happening out on the water, but sometimes it's fun to pick a day, well, fun or not fun. You pick a day where there was a very, very big, it could be a cyclone, it could be a hurricane, and we can see it in this kind of data set and where exactly it was and then how it moved over 4-hour integrated periods. And I thought it would be good for you to also see how these aren't the only kinds of data sets that we can place on Earth. Micah, can you turn on maybe the sea temperature levels? There's a lot of climate stories that can be told. This one is sea temperatures.
Sea surface temperature.
Sea surface temperatures. And these are probably integrated daily, I would think, right?
Correct.
Micah? So red should be warm, and blue to purple should be cooler. And we can go, maybe Micah, let's change it to 6 months later or something. Or you could probably go, I want something that'll make it, it'll be clear how it changes over time.
Yeah, so basically, now I went to summer, and you can see the bands are like lower, and if I go back ahead to the October, you see how it moved, the red is like moved way up.
And so we could do this with GIS data. So this is for Deja, who had some awesome data sets that could be used to tell a story about what was happening over Michigan. Oh, maybe we'll show the chlorophyll as well. There's an array of satellite data that you can show over Earth. And you can just download them and put them on top of the planet and then describe what you're seeing. It's very helpful to describe to the audience what might be happening on the planet. So, Micah, this one's chlorophyll.
Yeah, some kind of bloom off the coast of California.
Something's happening. I'm not gonna explain the science to you because it's not my science. But those of you that have interests in environmental science conversations, these kinds of resources are excellent for telling your stories. We did a climate change talk in here for the UN during Climate Change Week that went over really well. Micah actually did that with one of our other presenters, and there were some pretty high-powered people here. Yeah, Micah?
Yeah, the head of NASA, the head of the Saudi Space Agency.
I thought more like King of
the
Tonga.
King of Tonga, and some other delegates and representatives from other Austria, whatever the word is, the diplomat from Austria, etc.
Diplomat from Austria. Okay, so this is Earth. There's lots of stories we can tell on Earth. Just so you guys are aware too, yeah, we're gonna go to that in a second. There's lots of things that we could all complain about that are going wrong. One that I like people to know about that is a sleeper thing is a problem in space really close to your head, and that's satellites. So Michael, turn on the satellites that surround you, and this is just a portion of them. And Micah, maybe we can turn on, do we have Starlink in here? So these are the satellites that surround you. At this point, I think we have reached 10,000 that are in your near orbits. Some of them are near Earth orbits. Those are the ones that are spinning around the Earth very rapidly. Then you have these out here. These are called the geosynchronous
I
ones.
can add the Starlink in.
Oh, okay, do it, because it's so upsetting to see what they're doing. So it's basically Elon Musk has a company, called Starlink, and total sleeper, got permission to launch I mean, his initial, can you see this? This is what surrounds your planet right now. And there are two ways to look at it. One, space is large, there's a lot of space. But the problem is that if these things hit each other, there's something called the Kessler syndrome. It's a cascading problem because debris in space down to a fleck of paint is immensely dangerous because of how fast it moves. And so as soon as things run into each other, they create debris that can create more debris, and it's an exponential problem to the point that, has anybody ever seen the movie WALL-E?
Yeah.
Oh my God, I love the movie WALL-E so much. But you'll notice in that there's this really amazing animated scene where they show what it's like as they fly back to Earth, and it's surrounded by like a junkyard of satellite pieces. We have to be careful with our nighttime sky, because this is the only way to get off the planet is now through all this stuff. So you want to really, really, really pay attention, if you can, to what and how people are using the near-Earth orbit space. Starlink is an attempt to cover the planet in satellites so that we can provide internet for the entire planet. At least that's the claim, but it's a monetary venture by Starlink because you have to subscribe to them and pay them money. So they're making money on this. This is the problem. Once up in space, it is extremely difficult to get anything back. So people really, when even NASA science, they have to have an escape plan. So you either have to make it so you can bring it back, have an orbital decay so it burns back up into the atmosphere, or you have to have an escape plan where you push it out into what we call the graveyard area. So there's a graveyard for satellites way outside of the Earth orbit so that it's somewhere far enough away that we know that it wouldn't harm necessarily nearby space travel. Other countries, it's a mess. It's the wild, wild west of space. In the United States, it's regulated, believe it or not, by the FAA. The same people that regulate your airlines regulate the satellites launched. Now, I am not a fan of the current administration. I don't know why I have to say it like that, but I do. However, Space Force, even though it's nonsensical as a concept, it is so important to have a Space Force. There is a need to ensure that we are protecting the space above our heads. And that needs to be an international venture, because not every country can do the kinds of launches that we do. That's the thing. China, the US, Japan, India, these are the major players. Canada, Russia, major players, but they can hide what they're doing. We do not have a very strong unified take on what we call space diplomacy. All right, but I don't want to go all the way into the negatives. We can get away from Earth a little bit. So this is our little satellite structure. These are all the human-made satellites. We, of course, have our own satellite. Let's go to the moon, Micah. We're going to fly to the moon. And as we do, you're going to get a nice, beautiful, clear view of the sky. Oh, we just passed it. There's the moon. The moon is our celestial partner. One thing that's a fun concept to think about is what would life be like on Earth if we didn't have the moon? So the moon is such a romantic partner to the Earth, but it's also massive light pollution. It really harms your ability to see the nighttime sky. So as the moon comes into its full stage, you see less and less and less stars. And the moon is it's close to us, and it's a very large satellite. It was formed by something hitting the Earth, or at least this is the theory, by something hitting the Earth and then launching material up. Micah's taken us in, and now, does anybody know, is this the far side to the moon, or is it the near side? Is it the side we always see, or is it the side we don't see? What do you guys think? The side we don't see. Correct. How do you know that? Oh, well, okay. We could have had it fully illuminated. The key would be the side that we're on is covered in Mari, these like gray areas, and this is the pocketed side. I once did a Fox interview, I was on Fox, and they wanted me to talk about the phases of the moon, and they brought up this image of the far side of the moon, and they said, oh, look at that, and this is the view of the moon that we always see. And I had to correct the commentator in that moment and say, well, you've never seen that. No human sees that unless they were on the backside on a satellite, so the Apollo astronauts. But Mike is now moving us into the phase where you can see it. So right now, only 12 men have stepped foot upon the moon. Just 12 men and 12 white men. We've never seen a diverse crew of people head to the moon, but that's all about to change with the Artemis mission. And the Artemis mission is launching, and it's one of these aspects of space science that isn't cut under the new administration, at least not yet. There is a desire to go back to the moon, and the goal is to go back and bring the first women and a more diverse crew. At least that was what it was supposed to be before the new administration took off, and I don't think that that's changed. So the Apollo missions were the ones that went to the moon in the 60s and 70s, and Apollo was, of course, a male god. And so as the homage to the new stage that we're in space travel, where a more diverse group, and namely women, might likely be headed to the moon, they named this side of the mission Artemis. So they plan on heading to the southern area of the moon. The south pole of the moon is one of the main mission sites. Micah's bringing us down a little bit lower onto the moon. Micah, which data set do you have on?
I just switched on to the Japanese Kaguya data set to give us higher resolution.
So I was mentioning the different countries that are involved in space travel, and Japan has a ton of space-based programs. China, of course, I'm not sure how much people have been paying attention, but driving the United States right now to really have the Artemis mission is the race against China to get to the moon again, as China has a pretty strong desire also to be leading in space-based industry. So the moon has mountains, the moon has valleys, the moon has activity, the moon outgasses. The moon doesn't have an atmosphere though, at least nothing to speak of. So as Micah's flying, this is not an unrealistic take of what the day side on the moon looks like. You don't have an atmosphere to scatter off light. Oh, and Micah just did something awesome. I didn't see it, Micah, but now I do.
Yeah,
Everybody see, go ahead, Micah.
Coincidentally, this is like almost the exact flight the Apollo 17 came and landed in on, the last people who on the moon. I did that by accident.
Oh, nice. Good job.
Can we do
So
the
Apollo
footprints?
17 was the last mission to make it to the moon and then to return. It was a pretty long mission. They had rovers. They moved around the surface. They collected tons of rocks and samples. We have some of them here in the museum. If you go to the Hall of Gems and Minerals, or Hall of Meteorites, you'll see an Apollo 17 rock. I think that's where that one is. We have another one right downstairs, but I think that one's from one of the other Apollo missions. But you can imagine traveling on the surface of the moon, which some people will be doing in the next couple of years. They're going to do their orbit soon. The hope was 2026 that launch would happen, but that's just next year. So we'll see if that can actually happen. Sometimes I think, though, flying in the planetarium like this is a very good second to flying to the moon and then landing. Let's try another planet, Micah. Let's go over to Mars. Now, the reason why I'm going to take you to Mars is it is the next grand mission that people want to achieve. Getting to Mars would be a huge accomplishment for humans. And I don't just mean getting to Mars, because we've been to Mars with robots, but a human being stepping foot. And it's very hard for me to talk about it because the person that wants to go the most is Elon Musk. We could send him on his own mission. He can head there on his own. Right now, no one can survive it. And take that in for a second. This is a good nighttime sky. Everybody like it? So there's Orion again. And there goes, it's fine. It's the moon. There's Orion. On this side, does anybody know what this one is? Very famous nearby cluster of stars. Sometimes referred to as the Seven Sisters. No, this is the Pleiades. The Pleiades. Maybe Caprice said it.
Yeah.
Nice, Caprice. And then this here, this V-shaped thing, is Taurus. And in the V shape here, or this is the constellation of Taurus, this section here. But in this, and actually the Pleiades are in the big constellation. It's a bull in the sky, and it's of course a zodiac. But this is another, the nearest cluster to us. It's called the Hyades. It's about 650 million year old cluster of stars. The Pleiades is about 120 million year old cluster. All right, Micah's brought us here to Mars. That took us all of, 45 seconds to get there? It should take us, when we launch to get to the moon, it should take maybe a year to get there. So on your trip to Mars, you will be exposed to an enormous amount of radiation because the sun is radiating. And you've also taken us to where we have our...
Yeah, is that where you're gonna go?
Yeah.
Or, okay.
We're gonna head in to this gigantic canyon. So if people have people been to the Grand Canyon, maybe? Some Grand Canyon folks here, yeah? The Grand Canyon, it's gorgeous, it's sweeping, it's considered one of the magical components of natural components of the Earth. The Grand Canyon of Mars, what we call Valles Marineris here, and it stretches across the planet here. Now, its Grand Canyon stretches a length that is the equivalent of New York to California. That's how large the Grand Canyon of Mars is. It is a structure that maybe if you've ever seen the movie The Martian, do people see this movie? I think they did an amazing job of visualization in that movie, especially in the kind of the savior scene when they're coming to get him. As they approach the planet, they come in on this side, and you can just see Valles Marineris just out there for you. Then the other beautiful thing is to compare to, as I mentioned, the Earth, we looked at the clouds, the wispy white clouds. We've got this great atmosphere. It makes us so unique. The moon, I mentioned, has none. Mars is kind of in between. Mars has a very thin atmosphere. And Micah, you can just bring us down into a spot, and we're gonna turn on some high resolution imaging of the surface of Mars. Because once you're in the canyon, you can see all this intricate structure around you. And I always think that seeing it inside of the planetarium here is good enough for me. Elon Musk can go all he wants. I'm not interested in dying on that on that one-way trip. But it would be magical to kind of step down onto the surface of this world and see these wind-swept plains. And they are wind-swept, it's just the wind doesn't blow all that hard because it doesn't have a very strong atmosphere. If you were to stand on the surface of Mars, as Micah's bringing us down here to do, the temperature, because it's got so little atmosphere, it doesn't retain its heat the way that we retain our heat here on Earth. So the temperature from your toes to your head on Mars would be the difference between a summer day and a winter day, from your toes to your head. And so it's a question of, do you want to go there and experience that? I'm not sure you do. I think all of us were very cold in the Westin Curiosity Room. So Micah's got us in a great spot. This is as close to flying on Mars as you can really get. Micah, which map did you turn on here?
Here we have the high rise, which from the Mars Reconnaissance Orbiter, which has 25 centimeter per pixel resolution.
25 centimeters for every pixel.
So if Matt Damon was there, he would show up in the picture.
We could find him, is what you're saying. We could actually locate him.
And he'd probably be 3 pixels or something.
Yeah. But as you look around, you can see the canyon walls here. There's lots of debate as to what it is that caused the Grand Canyon of Mars, the Valles Marineris. It doesn't have plate tectonics the way that we do. That's just not the infrastructure of Mars. But it does have some hotspot plates. So likely, we didn't go to it, but maybe we will as we depart. The largest volcano in the solar system is on Mars. It's called Olympus Mons. And it probably just grew because you had this hot spot that let this area grow and grow, the shield volcano grow and grow and grow. But all around here, the thing that we think happens on Mars a lot is you get dust storms, and a lot of the structure that you're seeing here is some of the wind blowing all of the dust around. It's a very dusty place on Mars. It's also very dusty on the moon, by the way. One of the complaints that the astronauts had after they walked the surface of the moon is that they had dust everywhere. It went everywhere and they couldn't get rid of it. And so I think we're gonna have the same exact problem on Mars if we go. Notice also the way the sky looks. So I mentioned this about the moon, that on the moon, you would, on a daytime side, you would be able to see the stars. So on Mars, while I don't think you'd be able to see quite like this is trying to give you a sense.
The time, actually.
Oh, go ahead, Micah. What was that? The time? Do you mean the time of day or the time of year?
It's because I had cheated the lighting on Mars, so we're actually at Mars at nighttime. That's why we're seeing the stars.
Okay.
If I go to the daytime, then we wouldn't see the stars.
Yeah,
Sorry.
because, well, I believe one of the things I was going to give as your takeaway for Mars is that it's got a thinner atmosphere. It still distributes the light around, but it's a lot easier for stars to peek their way in to your ability to see during the day, the same way you can see Venus at night. Venus during the day, the morning star or the nighttime star. But this is the more realistic view of what the sky would look like on Mars. So hazy, yellowish, or orangey. It's a very rusty planet. There's no more water. We think that there was water at one time and that it all dried up or it's evaporated off of the surface, but it could be trapped or locked up in some of the rock, some of the planet, and that's one of the things that we have hoped to go find if humans ever go there, find where the water might be trapped, and to see if maybe Mars is a counterpart, sort of, that they could have had life on it at some point. Okay, let's leave Mars here. Let's take off from Mars. Does anybody have a request for another planet they'd like to see?
Neptune.
I just heard all of them.
Saturn.
We'll go to Jupiter because Jupiter's got a lot going on. So, Micah, let's fly in because one of the things that's interesting to compare and contrast is we take off from Mars, have a look at its atmosphere. You know, we can compare the atmospheres. It's a really important thing we do as astronomers. On Earth, we have our blue, the thin blue line that connects us. On Mars, it's the thin orange line that connects the Martians, even though Martians aren't real. There's no Martians. As we move away, Micah just turned down the high resolution. So those were high resolution images, and now we're on the low resolution global image of Mars. And then these are 3 of the volcanoes that pocket the surface, with the biggest one here, which is called Olympus Mons. It's taller than Everest. It sticks out of the atmosphere of Mars. It's so tall that it pokes its head out of the atmosphere. And so let's move over to Mars. As we move out, you can see we are no longer in the northern hemisphere or the northern sky. And you can tell that because you see these 2 fuzzy objects here. So that's one here and one here. These are called the Large and Small Magellanic Clouds. They are southern hemisphere objects, as is this structure here, which is called the Southern Cross. So 1, 2, 3, 4 stars. And then this little pair
Sorry.
here. Oh, it's okay.
Taking us to Jupiter, so it took it out of the way.
We lost that was the closest star to us. Oh, Micah just brought it back.
There you go.
So this star right here is called Alpha Centauri. You guys can't see it in the northern hemisphere. You have to go pretty far south to start seeing it. But it's a triple system, and Alpha Centauri is the brightest. Then there's another star in the system called Proxima Centauri that your eye can't actually see, but that's actually the closest other stellar system to you. So if you have to leave Earth and go to another star, you're gonna head in this direction. So I'm giving you directions. All right, Micah has set us up here. There's the sun, and then it's Mercury, Venus, Earth, Mars, a giant gap where we have asteroids called the asteroid belt, and then Jupiter. So we can head into Jupiter. Jupiter I like to call the bouncer of the solar system. You could stick the mass of everything except the sun inside of Jupiter. Jupiter is so massive. Mercury, Venus, Earth, Mars, the whole asteroid belt, Saturn, Uranus, Neptune, the Kuiper belt, Pluto of course, all can fit inside of Jupiter because it's that massive. It's a bouncer because it's so big it bounces other rocks around the solar system. The thing that you see as you come in is it kind of looks like its own solar system because it's got these giant moons around it. They're beautiful moons, if anybody knows these moons. You can see them with a telescope. If you go outside and want to have a look, you can see them moving around. It's actually one of the ways that we knew that we lived in another solar system. I mean, oh my goodness. In a solar system where we revolved around the sun and that not everything revolved around the earth. Because Galileo looked at Jupiter and saw as the 4 what are called Galilean moons, Ganymede, Europa, Io, and Callisto, all were moving around Jupiter. So, beautiful planet. It has these giant bands that go around it. It also has these kind of odd circular shaped objects here. Oh, there goes what I think was Callisto. The bands here, as we get closer, you can see that they make these like wave-like structures. My research team, or members of my research team, were here. We study the storms, not necessarily on Jupiter. We study them on planets and brown dwarfs outside of our solar system. But this is pretty common, we think, this kind of wave-like structure. First of all, it's banded, and second of all, these are storms that are going on the surface, doesn't have a surface, in the atmosphere. And this is a really big storm that's raging on Jupiter, and has been raging for several hundred years. It's a beautiful planet. If you've never looked at images of it, there's a mission that's surrounding it right now called Juno. And one of the best decisions about Juno was this thing called JunoCam. It's a camera, and it just takes pictures of all of the storms and everything that's happening on the planet. And it looks like art. It's art. It's watercolor art. It's dramatic. The colors are amazing. The structures are amazing. I mean, I think this looks good, but look up the Juno images. We don't actually have them to overlay, but Micah, we should probably do that. Let's look at some things outside of the solar system too. So let's talk about the stars for a second. So Micah, let's fly out a little bit so we get the solar system view. Now, as you look around, you see stars, of course, but then there's this thing that stretches up and around. And that is the Milky Way galaxy. And it always sounds funny to say that because, oh, that's the Milky Way galaxy. Because everything that you're seeing, really, as you're looking up, is a part of the Milky Way galaxy. But what this part is the bulk of it. It's if you think of the galaxy as like a flat pancake, because it is pretty flat, then this is the thick part of it, and we're staring out of it. And so you're looking at what we call the disk of the Milky Way when you're looking at all this stuff. And for us in the Northern Hemisphere, it gets high in the summer. And so this is the best time to look at the Milky Way is in the months of July and August. Even now, it's starting to get lower and lower in your sky just because of how the Earth being tilted 23.5 degrees and turning around the sun. We get different views of the sky as the year goes on. But in the summer, this galaxy will stretch. The galaxy we live in will stretch above you. Now, the stars that you can see in the sky are limited because your eye, while an amazing instrument on your body, it's a limited thing. So you can only see about 5,000 stars per hemisphere. And that's only if you're at the absolute pristine spot on the planet. We have low water vapor, no moon, the moon shouldn't be there, very, very dark skies, no light pollution. So you could try and count the stars right now, but just believe me, if you're gonna start counting them, you're only gonna reach about 5,000 before you're out. But there's way more here than your eye can see. And astronomers map those stars. So, just for those that were wondering, do we see this? It's an asterism here. This here is the Big Bear, or the Big Dipper. So, knowing your constellations is important. If you ever get lost at sea, find your constellations to help you navigate. What I'm gonna ask Micah to do is to turn on a different data set, which is gonna brighten up for you all these stars that you don't see, and specifically stars that are near you that you don't see. So in the distance of about 300 light years, there's about 350,000 stars. And so Micah, let's just turn on the Gaia catalog of nearby stars.
Oh.
So these are stars you don't see. They are too faint for your eye, and there are a lot of them. So if you actually could see all of the stars that are in your backyard, it would be an immense volume of light coming because you'd have to brighten them up, and you still have some of these bright stars that are just normal and far away from you. These stars also are moving. They're not staying still. It's just we don't live long enough to really catch their motion, which is why constellations seem to stay stagnant. But in the planetarium, we can make them move, which is what you would have seen us try and do in the space show. That space show was all about motion and movement. So Micah can make these move here, so we'll just turn time on. And now thousands of years are going by every second, and you're seeing the highway of the Milky Way galaxy. All of these stars are near you, and all of these stars are running around. So we're running around as they're running around. So we're on a journey. All stars are on a journey. This is just the vastness of space, and all of the great things that we get to do as humans on this planet is just kind of small compared to the craziness that's happening outside of this planet. And this is just our local neighborhood. This is just the stars that are what I would call spitting distance away from you. Let's reset and go back to the nighttime sky, Micah. The other thing that's important to know is that you're not alone in this sky. Starting in the year 1995, we started to discover in earnest that these stars, these very stars that are out here, also have planets around them. We haven't looked at every star, and we haven't detected a planet around every one we've looked at, but that doesn't mean that it's not there. But what we can turn on is all the stars where we have found planets. So Michael, let's turn on the exoplanets. And Mike, we can turn on the candidates too. So these are the ones that are confirmed, and then these are our candidates, which very likely have exoplanets around them too. So everything that's circled now is a star for which we've seen, and by seen, I don't mean necessarily directly imaged. I mean, we've detected the signature, whether it's because it's tugging on its star or because we saw the light of the star change because of it. But we have all indications that there's a planet there. And now let's go and have a look at where they all are relative to that Milky Way galaxy. So let's pull away, Micah, and let's see where all of these worlds are. And you'll notice a weird set in this direction. So this signature here is something called the Kepler, it was the Kepler mission. And it was a very powerful mission that found a lot of planets with a technique that we call the transit method. And the shape that you saw earlier was the shape of the detector as seen from Earth. But now as we fly away, you're just seeing the three-dimensional distribution of where all these things are. The world, the universe, the galaxy, it's all different when you see it in 3 dimensions. And so Michael will pull away, and now you can see everything relative to our galaxy. Now you can actually see this structure, which is, like I said, it's weird to call the Milky Way galaxy the thing that stretches across your nighttime sky, but it's really just referring to this disk, the band that we're looking through when we look up at the sky. Yeah, if you can go edge on, Micah, because that'll give us the view that lets you see how thin the galaxy is. The galaxy is much thinner than it is thick, which is why I call it a pancake. And so on this side, this is your Milky Way. All those planets, they look like there were so many of them. It's all kind of local to us. We can't actually see through the center of the galaxy, so we don't really know what's on the other side. We can make our inferences, and we have some ability to get through it, but it's really dusty, and there's a lot of stars, it's really dense, and so we can see this direction really well, but we can't really see on the other side of the galaxy all that well. Not through the plane of the galaxy, that is. Not through this stuff. And so all the stuff that's on the other side of the center of the galaxy, I like to joke, this is where all the aliens are. They hang there. We're on this side. I don't know what happened to us. We got stuck over here. But we can see really well in this direction. And then we can see up and below the plane really well, but it's hard to catch that. We're gonna keep moving out so you can get these views of the whole universe now. So this and this here, these two beautiful structures, these are those blurry things I pointed out earlier, the large and small Magellanic Clouds. They're satellite galaxies of ours. The Milky Way is pulling them in and will eventually eat them. They are getting gobbled away because the Milky Way is so much larger. And now every point that you see is no longer a star, but instead another galaxy with millions and billions and billions of stars of its own. And as we pull away, you start to see not just the structure that a galaxy is, which is made up of stars, but you're going to see the structure of our local galactic neighborhood. It's its own structure and highway of objects that are all moving. The same way I made the stars move, the galaxies themselves are moving. The Milky Way, while all the stars are moving relative to the center of the galaxy itself is moving relative to all these other galaxies. And we're moving away from it, but you'll see that we have it color-coded here. So there's orange and green and blue, and we can go back in just to see for a second all of the orange around us. It's color-coded by density, by the galaxies that move with each other. So we're a part of something called the Virgo supercluster. The Virgo supercluster. And it's all this orange stuff in here. Why are we a part of the Virgo supercluster? Nobody knows. Who knows? It's just our home area. The Virgo supercluster, we've discovered, is a part of an even bigger thing. And so as we fly out, you can see that there's even larger structures, not just these overdensities, but that these overdensities are actually look like they're kind of a part of some webby structures. And the part that we are a part of is something lovingly called Laniakea. Laniakea is our very large structure that looks like it's all kind of co-moving together. It's a very, very, very large extragalactic structure. And you can see as you pull out, which is what Mike has been doing, this structure upon structure unfolding. Now these are hundreds of millions of galaxies that clump together. There are hundreds of billions of stars in each galaxy, and then there's hundreds of millions of galaxies that will form superstructures. And it's a fascinating structure, the hierarchical structure of the universe, where you've got long areas where galaxies clump and then gaps in between them, what we call voids, where there are no galaxies. But is there nothing in the voids? We don't think that there's nothing. There's likely a lot of material that you can't interact with, that you can't see. We call that material dark matter. It's a very mysterious component of the universe, but it looks like maybe almost 30% of the universe is made up of it. It drives a lot of the structure that you're seeing with these voids, these gaps in between clusters of galaxies. It gets galaxies to clump together really nicely. And believe it or not, I mean, this is kind of when I found this out, my mind was blown when I was a kid. What we are made of, what we call baryonic matter, is only about 5% of the universe. As I said, dark matter is probably 25-30%, and then the rest is this odd thing called dark energy that is pushing the galaxies away from each other and causing an expansion to the universe. So you think we have problems on Earth? The universe has got a lot going on. So anytime you start thinking about politics, just switch over to astronomy and it'll help. It just helps. It just helps a lot. So we'll keep going to the edge of the universe. Mike is taking us out, and you start to see that the structure falls apart because we're going way back now. These are the oldest galaxies. It's a weird way to say it because they're really seeing them in their infancy. These are the first galaxies. These are the galaxies that first formed after the universe itself was created. These are called quasars, or quasi-stellar radio sources. They have supermassive black holes, many of them all galaxies have supermassive black holes at their centers. But the structure kind of breaks down, and we don't know what that is about and whether that's real. Many surveys are coming online that are going to help us map out how many galaxies are out here and what they look like. And then Micah took us to this view. This is the real edge of the visible universe. It's this thing called the cosmic microwave background, or the CMB. And so see how it's blue and red. This is actually showing you hot spots and cold spots. Where we think in the moments after the universe was created, after the Big Bang, you had tiny temperature fluctuations. And those tiny temperature fluctuations ended up propagating into the very structure that we see today. And so we look at this cosmic microwave background as a blueprint to the structure that we have today. So it's like forensic evidence where we're trying to solve the structure of the universe by using all of this here. All right, let's head back all the way in, Micah. Through the quasars, through this kind of non-structure that happened after the universe was formed and these galaxies, while there's still billions of these galaxies out here. As we get closer and closer to our place in the universe, you see that structure come back to life with this insane web, the galactic web, the extragalactic web. And then onward and inward. You might notice that as we came in, we kind of hid that it looks like a butterfly. That's not real. The universe doesn't look like a butterfly. That's just an observational difference where we haven't actually imaged this area of the sky the same way we did this. This area was imaged in the northern hemisphere of the Earth, and then this is a little bit in the southern hemisphere. And it's really hard to actually do the plane of the Milky Way, which is why this area is kind of blank. It's just where we've pointed the telescopes. But it doesn't matter, every time we do point the telescope in a direction, you see that same web structure. It's not like it's non-uniform, it's in every direction. This is our local galactic area, all these galaxies piled up on each other. As we get closer to home, these are the, no human that I can imagine knowing, or at least not in our current form, will ever make it to these distances, but we do know these galaxies are here. And we do think that our galaxy looks like this, though we will never have this image. We just model it as best we can from the data that we have. And then we can keep going all the way in. Remember, these dots here are all the planets that we've found. And so there are now thousands of planets that we've detected and studied, and are learning so much about how diverse other worlds can be. And there's so many more to discover. Many of the planets that we found are not as similar to us. We have yet to find an Earth twin, even if that can even be a thing, that we're ever going to find an Earth twin. But we look. Many telescopes are hoping that they can look to the ones that are rocky and have atmospheres and search for those biosignature signs that there might be life on them, maybe intelligent life, hopefully more intelligent than we are, at least more intelligent than what our political system seems to lead us to believe we are. And there might be some hope of communication. I'm not of the opinion one way or the other how it's going to go down, like whether there is intelligent life that we'd be able to contact or not. I think it's profound either way. Mike has taken us back home. The one thing that we do know is that we exist and that life emerged on this planet, and it's a crazy biodiverse world. So many different kinds of life forms on the planet, at least different habitats, different survival lengths. So much interesting life on this planet that it's hard to think that that wouldn't be captured in this diverse collection of worlds that you see all around you. And we'll come back in. Just remember you have to protect your skies, because we're going to come back in and the satellites are probably on. I just want to remind you how important it is to protect your nighttime sky, because if we're ever going to leave Earth, you're going to have to do it through all this material. And I think there is some hope that we will get there someday. Okay. That is our dome. That is our dome stuff for you guys. Do you guys have any requests of anything you want to see inside of the space? Where the black holes are? Yes, we get asked about black holes all the time. People love black holes. But there's not a lot to visualize for a black hole. We have a black hole at the center of our galaxy, but you don't see it, you see all the stars orbiting it. There should be a catalog, and Micah, I keep saying I want to build this, but a build of the actual black hole, catalog of black holes that have been detected, stellar mass black holes that are in the galaxy.
Yeah, don't Savick and Barry have that?
I don't know that they've ever built a stellar mass black hole catalog. But you worked with them on their Frontiers lecture, right?
Yeah, and I thought they were going to give me that. Didn't.
I don't think they did, yeah. But I can build one because Gaia has found a bunch of them. But all it's going to show you is where they are.
Which
It's
might
not
have
going to
been
show you
the
what they
question.
look like. What was that, Micah?
That might have been the question.
Yeah, I mean, we don't, right. So if the question is where are they, we can make that catalog happen. But we can't make a catalog happen, or we can't do an imagery where we could fly you up to it and you could see what it would look like around it. Because it also would just look like chaos and it would kill you. So yeah. All right, anything else? Do you guys have any questions? Anything at all? It's very unique to be in. Yeah, go ahead, go for it.
Of all the planets that you found around stars, have you found any stars that don't have planets?
So it's very hard to be sure that you've looked at a star and you could outrule any kind of planet because our observational techniques are limited. So you could always stick a smaller planet close or a little farther away from the star and we wouldn't be able to detect it. So that's the biggest problem we have, is that our technology isn't good enough to find all the worlds that we want to find. It's really hard to find an Earth-like planet around a sun-like star. Like, we're only just barely able to do it around the closest stars to us. So there's no way to outrule it entirely. Caprice, you got something?
Are there brown dwarfs in here that we can see?
We have, Mike, you can turn on the brown dwarf catalog. All we have for brown dwarfs is their locations on the sky, but you can see where they are. So this is a catalog of all of the brown dwarfs that have parallaxes, so we have measured distance to them. So these are these objects that are in between stars and planets that Caprice also studies, and they have mass, they don't have enough mass to get nuclear burning at their cores so that they don't shine like stars do. They cool through their lives. And there are tons of them all over your sky. But your eye is never gonna see one because they're too faint. But they are everywhere. And the way that they're color-coded here is by their temperature. The purple ones are the coldest ones. Micah's got us over, yes.
Everest.
What do we call those mountains? Oh my God.
Himalayas.
The Himalayas. All right, anything else? Or shall we go have a glass of kava? I heard some kava.
Do you have any beautiful spots on Jupiter? I mean,
We could go to Enceladus as our closer. Enceladus is my favorite astronomical object that exists.
It could
It's
just teleport us there.
teleport us. Yes, Micah, teleport.
Ta-da!
This is Enceladus. I think Enceladus is the best world in the solar system, aside from Earth. And that is because it's it's what we call an ice world. It's frozen, it's very cold, but we think it's got this gigantic ocean. It's covered by an ice sheet. And the thing that's magical about it is Cassini noticed that if you can go to the Terminator, Micah, yeah. Oh, we have to light it all the way up to get to the Terminator. It's got these structures. You can see some of them here. And they look like kind of little bent out valleys. And this is the big side. They're called tiger stripes. And what Cassini saw was geysers flowing out of these things, just blowing off like crazy. Which means that it's blowing material from that ocean. So if there's life, you could fly over them, stick out your tongue, take a lick, and maybe taste some Enceladin stuff. Totally possible. So this, I think, is one of the coolest worlds that exists.
First time I've heard the word Enceladin.
I think I made it up just now.
It was pretty awesome. It flowed very smoothly.
It's it, right? Yeah, it's a total flow word. All right, let's close up this. Everybody thank Micah because he was a last minute addition. Just remember, you can use this visualization software too, if you like it, for your scientific communication needs. And we've got some wine and cheese and crackers upstairs for our closing ceremony. We'll turn the blue lights on too.